All right, well, howdy. So I want to start with conservation of energy, and I'm going to do this with the analogy of the blocks. Okay, so the story is this. Okay, there's a child and a mother, obviously, because, you know, children have mothers. It happens. And that child lives in a room. He has his own room, right? And, you know, he's got a bed in his room, and he's got a toy box. There's a door to get in the room, and there's a little window here. Let's make it a little bit bigger a window, and let's leave it open so that he can get a nice breeze. And outside of his window, there's a little pond with some ducks in it. All right, so he has a nice little room, you know, sitting there out somewhere idyllic. And at some point, his mother decides that what would be nice is if he had some blocks to play with. So, you know, she gives him some blocks. She gives him, let's say, 25 blocks total. And these blocks, you know, the boy plays with. Now, when he plays with those blocks, he brings them out onto the floor. Okay, so this is sort of the active area on the floor over here. And he has all these little blocks that he piles up in different fashion. And, you know, his mother can tell, you know, that if she comes in and she sees these 5 blocks or 6 blocks that he hasn't put away, you know, he'll have, let's say, 6 blocks. 6 blocks, and those are sort of active, and he's playing with them. And she knows, or at least she hopes, that he'll put them away in the regular place usually, which is the toy box, right? So there's a toy box here, and so if there's 6 blocks out here, she's hoping that there are going to be 19 blocks on the inside of the toy box. Okay. So that's, you know, an interesting sort of thing. She can make a little equation out of that. So she's going to have, say, the total number of blocks is equal to, let's see, the blocks on the floor, F, plus the blocks in the toy box, T. So that seems pretty reasonable. So, you know, every once in a while she'll come in and she'll clean up the blocks on the floor, and she'll put them in the toy box, right? And when she opens up the toy box and she puts them in, there'll be 19 blocks in there, and she'll know that all 25 of the blocks that she bought for her little boy are all safe and sound in the room. Now, unfortunately, that doesn't always happen, right? Sometimes she picks up the 6 blocks, she goes over to the toy box, and there are only 17, or maybe let's say there are, not 17, let's say there are, what would be a good number? Less than 17, 15, 14. 14 blocks, all right? And those 14 blocks and 6 blocks, that means 20 blocks. That means there are 5 blocks unaccounted for. So where could those blocks be? Where did those blocks go? Well, maybe she looks under the bed, and maybe there are 3 of them under the bed, right? Which is a sort of a place where he wouldn't be playing with them, but, you know, turns out that lots of things end up under the bed all the time. And she sees a couple of lumps here, sort of squarish lumps on the bed under the sheets. So maybe the boy put a couple of blocks in there. So that's 1, 2, 3, 4, 5. 6 plus 5 is 11, plus 14 is 24. So let's call the bed D, because we already have the B for the number of blocks. So D is going to be equal to 5. Okay, so D is equal to 5. And so now we have 6 plus 14 plus 5, and that's going to be equal to 25. That's all our blocks. So what has she done? She's gone through and she's been able to count these, and she counts the blocks on the floor, and counts the blocks under the bed or in the sheets, or whatever the, you know, blocks are, and they end up being 25 blocks. It's very good. But, you know, sometimes the boy isn't really that organized. Sometimes he'll do some strange things, like end up with blocks out here in the hallway, right? So if a block out there in the hallway, it's no longer in the room. So if there was a block out there in the hallway, and maybe it was behind the door or something like that, or, you know, under a little shelf or something, and she didn't notice it, she comes in, she finds 24 blocks in the room, ones outside of the room, that's bad. But, she can go off and she can look for it and find it, bring it back into the room, and it'll come back. So a lot going out the door can, in principle, come back in, unless, Dad confiscates the blocks that he finds in the hallway because, he wants to teach the boy a lesson about putting his things away. So that's all dandy. So, things are working out pretty well. So we've got a system, if there are blocks on the floor, those are blocks that the boy can play with right now, but if he wants to play with more blocks, he can go into the box and get them, and if he's happened to put some blocks accidentally under the bed, he can grab those. So all those blocks are available in the room, so maybe 24 of them. And then, maybe he throws one out here. That's not really available to play with because it's not in the room, but, in principle, somebody could bring it back in. He could, or his mother could, or his dad could, or his sister could. Something could happen. That block could come back into the room pretty easily. So then one day, his mother, he sees the block in the hallway, or she sees the block in the hallway, she picks it up, brings it back into the room, starts cleaning up the room, puts everything back in the toy chest, and she only sees 24 blocks. She only sees 24 blocks. Well, what happened? Well, what obviously happened was the boy threw a block at the duck. So the boy has this block, and it's fun to throw blocks at ducks. So he threw a block at the duck, and now it's over in the pond, and it's never coming back. So unlike the door, if you start throwing your blocks at the duck, no matter how fun it is to throw blocks at ducks, you don't get your blocks back. Right? And so this is sort of a little analogy, right? So you can sit around here and you can think about this. We have a little equation here that says how many blocks should be in the room, right? As long as the blocks don't leave the room. We have two ways for the blocks to leave the room. We have the door and the window. The door can, in principle, transport blocks back in and out. The window could as well, but it's very hard to get blocks back in the window, so that basically if you throw a block out the window, you lose it. And if you miss your duck, then you lost all your fun. So that is sort of the allegory of the block. And what is this an allegory for? Well, it's an allegory for energy and energy conservation. This is like a conservation law right here. The number of blocks in the room B is like the total energy of the system. All right. So as long as you're transferring the blocks in and out of these different places where you can store them, you can store the blocks under the bed, you can store the blocks in the toy chest. They're always available to use, they're just in different places. You have ones that you're actively using on the floor, and you have some in the toy chest, and you have some under the bed, or maybe in the bed, because you're a little boy. And you really like your blocks, right? So that's what's the conservation of energy. But we also get a couple of extra things in here. The blocks can go out this door, right? And that is sort of like work. This is the door of work. And then they can come back in and come back out. Here we said on the floor we have these things we're actively using. That's kinetic energy. So the blocks on the floor are like kinetic energy. And these other ones that we've stored things in, the toy box and the bed, these are both potential energies. We'll talk about potential energies in the next video, and then we'll talk about how to put them all together to solve some problems in the last video, which will be on conservation of energy proper. So this would be, let's say this is the gravitational potential energy here, because there's only one way to put things in it. You can put things in and you can take things out, but that's about what you can do. But you can put things either up on top or down on the bottom in the bed. So the bed is like, let's say, the spring potential energy. So if you have a spring, that also has a potential energy, and we'll talk about that in a moment as well. We have one last thing, which is throwing things out of the window at the ducts, and that is heat loss, that is heat. So that heat is, one way we lose energy all the time. So, if we had friction or something that would skate across there, that would be heat. That creates heat, and it's gone. We can't get it back. We can't keep the heat back. So that sort of tells us all of the things that we can do with energy. So we have, in the end, our conservation of energy. We'll talk about that later on. I won't write an equation for it right now because I don't have enough room. So that is sort of what we're going to do with all of this energy stuff, is we're just going to kind of account for things. We're going to use energy as an accounting method. Really, I mean, it really is just energy accounting. And so much of physics actually is energy accounting when you get into it pretty deeply. So this is what a lot of people do in physics all the time, is just account for energy. What's going on here? Where is it going here? Where is it going there? How does it get lost? What sort of other things are conserved like this? This is actually an analogy for all conservation laws in a way. And there are many conservation laws in physics, although we'll only use a few in this class. All right, so thank you very much for listening, and I will get to a new video for you right away. Bye now.